The visually impaired now have a tool that can guide and empower independence. At CES 2025, the WeWalk Smart Cane 2.0 made waves as one of the most innovative solutions for individuals with visual impairments, redefining how mobility aids can integrate cutting-edge technology. I am excited to speak with Song Lee. He is the product marketing director for InventSense, a TDK group company. Thank you for being here, Song.
Thank you, Sharon, for having me. We work and the TTK InventSense, we work closely together to help We are as a sensor supplier. We provide all the key sensors that help to enable the new features of a smart cane 2.0. And then so this is a traditional like white canes, right? For vision impaired people hasn't changed over a century. And then one of the co-founders at the WeWalk, from his really personal experience, he's also a vision impaired person, right? From his own experience, and then he feel, yeah, this is really a time that they need to do something to really improve the life quality, and then the safety, and then improve the mobility of a vision impaired community through this new innovative product, right? And then the key for this product to be successful is that they really need to be able to know everything that surrounds them, right? When they really walk either outdoor or indoor. And then so they survey a bunch of sensor providers and eventually pick TDK product due to our great support. And then also all our product are in a small package size, which is important because they don't want to, by adding sensors, increase the size of the cane, right? They want the people still hold it the same feeling of the standard cane. And also, yeah, all these sensors are consume less power. So yeah, it's really support like all day usage experience.
So I noticed that you said it was Smart Cane 2.0. So were were the sensors in the original one also from TDK?
No, the original
No.
one, yeah, it's not. But also the
Okay.
original one doesn't have lots of those key features like the overhead obstacle detection. That's not included in the first one. And then yeah.
So how did TDK get involved with WeWalk? Do you know?
Yeah, I think this is started when we were at the Embedded World Show. This is like 2, 3 years ago. I don't remember exactly. Yeah, but it's in the show. So they visit our booth, and then we had a talk, and then I think that's all this started. Yeah.
Great. Yeah, collaboration through networking. That's fantastic.
Yeah.
So uh, can you speak to the user feedback and that of WeWalk's inventor, who is blind himself, how that influenced the development of the 2.0 Cane's design and functionality?
They not only from the co-founder himself's personal experience, that's one part of it. They also like work closely with the community, right? Vision impaired community to get their feedback. I think some of the feedback like be able to detect above the ground obstacle, right? And also, yeah, basically make this more like resistant to like a rain, different like weather scenarios, right? So those are some of the feedbacks from their working with the community, and then from their own personal experience, right? And then that's really trigger, prompt them to really have this the second generation design, and then with much more sensor, more intelligence. Yeah.
So why don't you talk a little bit about the artificial intelligence component, improving the UX, and then we can go back to the components that are actually in the cane itself.
Yeah, the artificial the AI features, yeah, today is like a very popular or key features for the new product, right? And then the same thing apply to the latest to the new smart cane. And then so they they actually, yeah, based on the ChatGPT model. So they create a language, a large language based on the large language model, right? So then they can really convert to like in the daily plain language, English language or whatever language they're using, local language, right? To really have an effective communication with the cane. And of course, the cane also had a connection through Bluetooth with a smartphone. And then they run apps on their smartphone, right? So they can use the plain language to really give instruction or interact with the cane to basically tell them something like show me the closest nearest coffee shop or take me to a bus station, right? So this is kind of normal language, and then the cane or the app will respond with a really more accurate navigation direction, and then give them like a turn by turn instruction to go there. And then of course with the on the cane we have a motion sensor that even they can track their progress of how they follow the navigation, right? Let's say if at a certain point they make a wrong turn, the gyroscope on the IMU can sense that and then then the cane may tell them, hey, you make a wrong turn, please turn right instead of turn left. One of the challenges is really how to make sure the ultrasonic time of flight sensor can accurately or consistently detect the obstacle that like overhead obstacle, right? And then that involve a lot of try and error, and then also the algorithms behind when you receive the signal and how you really characterize it, right? As an obstacle, and then also send that information in real time to the processor or to your apps, and then to react. So yeah, for that one, I know we work together with WeWork. We did a lot of tests, and then to make sure that function is really meet the WeWork's requirements. And of course, for IMUs, there's always like even we talk about the context awareness, right? So those we also have to collect enough data, and then using maybe even machine learning algorithm to really make sure that they have a correct, they are really can accurately detect those. And also we don't want to create too much like false positive type of scenario, right? And then also I think in some cases, right, they need multiple sensor to be like work together, and then to create some form of sensor fusion to be able to detect certain application or scenario, right? Like even for this, if you're in the navigation scenario, so the IMU needs to really track the speed, and then the orientation, the direction the user is traveling. And at the same time, if there's happen to be an obstacle in front of them, right? So then the time of flight sensor will detect that, but also they will use the speed information from accelerometer to detect, yeah, how urgent this is. And then they have to really promote the user to really change direction, or maybe they can really say which direction should we go. If they, yeah, if they have they can really even not direct front, they probably even look some like environment near it, and to make sure that direction there's no obstacle, so they can direct customer to do some avoidance, to do something, right? So
So
this a lot of sensor fusion happen in the background.
yeah, I like that. I like the term sensor fusion too. But I'm curious, we've talked a lot about the app, and I'm curious if the app stops communicating with the cane at any point, um, is there like a backup plan within the cane itself to let to let the user still be able to use the cane even if the app happens to like
Uh,
fail in some way,
okay.
shape, or form.
So I think one thing I'm sure is for the obstacle detection, it doesn't really, even without an app, it will still be able to detect obstacle and then send the beep or the vibration, right? Yeah. And
Hmm.
then also the frequency will change as in terms of the distance between you and the obstacle. That one doesn't really rely on the apps. But
Okay.
of course, if you're talking about the navigation function, then of course that's need app to really run the Google based on the Google map or yeah, to give the turn by turn instruction, right? So without app, those function uh, will not work. Yeah, but still the obstacle detection and then maybe even the pressure sensor. And then yeah, it can do certain with the IMU. It can even without app, they can still sense the environment around it, right? And then like it can detect if the cane is lying flat or if it's against the wall, like turn off lower the system power consumption to preserve battery life, or yeah, or they can send some stress signal. But of course, this will still need to go through phone to send it out. But there's the cane also have a very strong flashlight. So if that things happen, if locally they can just turn on the flashlight to basically bring people
To
nearby.
help them. Okay.
Yeah, to me, if there's a failure, it's most likely it's the RF chip that causing the failure. It's not really the antenna because they just send out those whatever the current it inject into that metal piece, right? It will
Hmm.
just start to yeah radiate, right?
Right.
But it's, yeah, usually that's really the RF chip that's which is
And then
not.
there's times too when phones die. I mean, sometimes we don't always all charge our phones, and
Mhm.
aren't ready for the,
Yeah, yeah,
sometimes
exactly.
it didn't charge overnight or whatever the case may be.
Yeah.
So that's kind of where my thinking went
Mhm.
because you really do become reliant. Once you have a technology like this, I would think you really become reliant on it. What other industries do we often see these Invensa sensors in?
Yeah, so for the IMUs, the biggest market is the smartphone. So basically today, all the smartphone, if they use the optical image stabilization to give you to give you a high quality picture while you're on the move, right? If you have a shaking hand, right? So that one is really gyroscope is the really the key. It can sense at any moment there's a angular change because of the hand shaking. Then the motor of the camera will compensate those kind of shaking, right? So that's one thing. And then today, another one is really the AR VR glass. So yeah, that require IMUs on the glass itself to track your head movement and then to really yeah being able to really do all their magics, right? And of
Right.
course if you some of them also come with a controller when you use it as an input device or as a gaming input device, right? So every controller there they need one IMU. Yeah. So, and then of course, the next big thing probably is a robotic, right? The human droid. So that's also, yeah, anything on the hands or on the joints, they need multiple IMUs on every one of those robots, right? And then we have the product that really defined or well positioned to support those applications. And then in some of the area we are a truly market leader already. Yeah.